All right, so we're going to try and figure out the equilibrium constant. They've told us here they want us to solve for a Kp. And what that means essentially is that with a Kp, we have to have only gases that we're dealing with, and we do, so that works out really well. They also give us the equilibrium concentrations of all these things, which means essentially that we have to write the equilibrium expression first and then plug the numbers in to solve for our Kp. So as a gentle reminder with Kp, we take the products raised to their coefficients, as long as they're gases, over the reactants raised to their coefficients. So if we take a look right here, our product right here, don't we have Br2 as a gas, and the coefficient we have there is a 6, which is a pretty high number, right? So, and actually we have 2 here. I don't want to ignore the first one, so I don't know why I decided to jump at this one, but let's do the P4 first. So we're going to write P, and then we're going to write the pressure for 4 raised to the first power. We're not going to write the 1 there, we're just going to write it like that. Then we have the pressure for Br2, and it's going to be raised to the 6th power. All of that's going to be over the pressure for PBr3, all raised to the 4th power. I mean, this altogether is a pretty ugly thing. And again, I want to remind you that what we did is we took the coefficient there, we took the coefficient here and put it here, and then we put the coefficient here and we wrote it here. That's only because we have all these are gases. If one of them was a liquid or a solid, they would not make it into our equation. So since we have this equation already, then it's just a matter of plugging in the numbers that we're given over here in the table. So how is that going to look? Well, we're going to write Kp is equal to, and we don't have to put units for equilibrium expressions because they can get kind of wonky. So I'm going to leave them out because we're allowed to. 88.4 times 30.3 raised to the 6, all over 79.3 raised to the 4th. And again, if you're wondering where I got these numbers from, each of these right here, I took here and put it here, and I took this number right here and put it here, and of course, lastly, this number right here, put it here. So if we do the math on this, and because of the magic of doing things off screen, I multiply it out, I end up with a Kp that's equal to 1.7 times 10 to the 3rd. Now, this is bad significant figures here, so it should probably be 1.70, but this is the answer that ALEKS gave, 1.7. So I would say it's 3 because we use 3 significant figures all the way through the entire problem. But again, take a chance here if you write it as 1.70. If they say sig figs, write it as 1.7. Hopefully this has been helpful.